Hi, everyone. Thanks to the organisers for inviting me tonight. It's good to be back. I want to share some experience that we've had with clients of ours, helping them to take a monolith or monolithic software and work out an appropriate way to split it, but keeping the team front of mind. So today, we'll look at a few things. We'll look at something called cognitive load and how that applies to teams. We'll look at what we mean by a monolith, because it turns out there are many different kinds of monolith. We'll mention briefly something called code forensics. And then, well, actually, the order of these points is slightly wrong. So then we'll actually look at a monolith splitting recipe that we've kind of come up with based on our experience. If we get time, we'll have a look at some real examples with actual client logos on, but we might run out of time. Let's see what happens. So for now, we're going to forget a few things because there isn't time. We're going to forget about microservices. We're going to forget about CQRS, and event sourcing. We're going to forget about queues and all sorts of things. These are really important. The stuff I'm talking about today points us in the right direction for architectural changes like this, but we're not going to talk about it today. And it's worthwhile being aware that this stuff is pretty heretical. So if I should be burned at the stake like a medieval witch for saying some of these things, but that's where we are. So I'm the co-founder at Skelton Consulting. We've been going about 3 years. We've got clients in different places around the world. And we build modern capabilities by mentoring your teams. So we don't build stuff and hand it over. We build things and mentor people alongside people in your organization. And that's how we've come up with this experience. So it's actual experience that we've had. This is kind of how we see ourselves in the engine. That's not my backside, but it kind of metaphorically is. We're in the engine getting our hands dirty doing things. But today we're going to look at this, how to break apart a monolithic system safely without destroying your team. Why do we care about that? Well, we want to be able to make safer, more rapid changes to software systems. And what that gives us is business agility, organizational agility. That's how to sell these kind of ideas to people in the business with who hold the money. If you need funding to make some of these changes, you talk about business agility, organizational agility. That's ultimately what we're trying to achieve. And this is a team-first approach to software. We start with the team. You'll hopefully see why that's important in a minute. But when we say team, people have different ideas about what a team is. Some people think a team is just a collection of people who share the same manager. And that's the most common kind of team, sadly. But that's not really the kind of team I'm talking about. I'm talking about putting the team right front and center. And that's the team as the unit of software delivery. That's where the team is the thing that we think about in terms of skills and capabilities. What's the appetite of that team to do things? How often as a team how often do we ask a team, what are you interested in doing? What are you interested in doing if you had some training? What are you definitely not interested in doing? And ultimately, what we found is that many of the problems that occur in organizations trying to build interesting software is that the boundaries of responsibility have not been clearly defined at all. So getting to the point where we understand where the boundaries are, whether they're, if you like, clearly defined boundaries or whether we deliberately allow some blurring, just some clarity on that is massively important. And I've got an assumption here that the team is stable and slowly changing. It lives a long time. We have time for the team to grow, to form, and be able to perform well. We do not spin up a team for 3 months, do some work, then dissolve the team, then spin up a brand new team with different people for 3 months, and then dissolve that team. So that's what we do not do. What I'm talking about is keeping the team stable. It changes very slowly, and we bring work to the team This is something that Alan Kelly talks about. We bring work to the team so the team itself remains the same, even if we have to have a project-based delivery. We need to know about Conway's law. If you're playing bingo, then you can tick off one buzzword bingo word. Conway's law, I mean, it's a really, at a very high level, Conway's law talks about some sort of relationship between the structure of the organization and the structure of the software that we're going to build. And it's the communication structures which Conway focuses on. Again, a very simplistic level. It looks like this. This is super simplistic. If we have 4 teams with, in blue, front-end developers, in green, back-end developers, and we've got, in orange, a single lonely database administrator. It usually is just a single lonely DBA, right? Then, if we turn that through 90 degrees, then the implication of Conway's law is it will end up with kind of a UI layer, an app tier, and a single shared database. Very simplistic, but this is the kind of implication. Now, if you want that, that's fine. If we don't want a single shared database, then we can use something called reverse Conway to try and anticipate the software architecture that would naturally result from Conway's law. So if we want a kind of microservices-y architecture like there is on the right-hand side, then bring a data capability into each team. So again, it's super simplistic, but I'm just trying to emphasize the point. There is some sort of relationship that means if we want a certain kind of software architecture, there's a certain kind of team structure and composition which would more naturally produce that software architecture. Alan Kelly, again, calls this the homomorphic force. So there's a force that tends to produce the same shape between the organization and the software architecture. What we want to do is not be fighting that force. There's plenty enough other challenges building software. We don't need to fight against this kind of Conway's law force. Let's try and align ourselves to that. There's something else we need to take care of, and that's cognitive load. Cognitive load is the total amount of mental effort being used in the working memory. It's really important for situations like software development and production engineering, where we need to keep a lot of things in our head. There's different kind of cognitive load. There's intrinsic, which is things like how a computer works, the kind of registers, RAM, CPU, networking, that kind of thing, which we just naturally have at the back of our minds. Extraneous or irrelevant things like, oh my God, how is it that I have to log into that remote system to pull the config and then deploy it? Boring stuff which shouldn't be there. And then germane and relevant things where these are things that are extremely valuable to the problem in hand, like something to do with that particular domain that I'm working on. That are valuable to have as we're writing the software. There's a really good talk by Joe Pierce. This was at OSCON, I think, last year, called Hacking Your Head. So if you're interested in how cognitive load applies to individuals in software engineering, have a look at that talk. There's a video online and slides online. But in terms of how cognitive load applies to teams, there's actually some recent academic research. So we've got science at work, which is great. There's various studies that I list out in here. These slides will be online later, so you don't need to copy the details. But there have been many studies, and one of which concludes like this. Stress impacts team performance by narrowing or weakening the team-level perspective required for effective team behavior. So what's going to happen here is if we give a team too much to do, if the cognitive load is too high, that single unit of delivery begins to dissolve into the individuals. So we lose the effectiveness of that high-performing team, which we don't want to do. So we definitely need to be cognizant of the cognitive load that we're asking that team to take on, which implies that there's a limit, there's a maximum size of software subsystem, component, service, because there's a maximum team size. Depends on the situation, but there's a maximum of roughly, say, 9 people in a software development team. So the limit on the size of the subsystem that a team can deal with. So what do I want to share with you? Yeah, so I'm not an expert in cognition, but I do have some background in brain science. I've done some research into speech perception, and a long time ago, I built some software for medical imaging, for brain imaging. That's in Delphi 5. Who's written in Delphi 5? Awesome. The best language ever. Anyway, so I'm not an absolute expert, but I have some additional context. It's not just through reading, New Scientist magazine or what have you. Let's have a little, so we'll come back to some of these themes in a bit. Let's have a little look at monolith. What do we really mean by that? So the word monolith comes from Greek, meaning single stone, and there's how to split an actual monolith. You put little pegs in the top and you hit it, and then it kind of splits in half. Two quotations now, two quotes. So Stefan Tilkov from InnoQ. Don't start with a monolith when your goal is a microservices architecture. Okay, seems fairly reasonable to me. Thomas Saleh from Pivotal says, start monolithic and extract. The complete opposite. So what's going on here? Because you're two very experienced software people. I think what's probably missing, or might explain these two opposites, is that they're not considering the team element. And they're talking about different contexts. And if we actually start with the team, then we might produce a more comprehensive way of splitting things. There's many different kinds of monoliths. So an application monolith where we've got all of the stuff in the same application runtime container or whatever, that's monolithic, so one big jar or one big PHP blob or whatever, fine. But maybe we've got applications which are joined at the database. We've got a central database. That's actually a kind of monolith because it still makes it quite hard. There's a high degree of coupling there. Maybe we've got separate components, but we build everything together. So there's a monolithic build. In many places, we have a big monolithic release. So we've got lots of separate bits. They deploy them separately, but then we decide to couple everything together and deploy it all as one. That's also monolithic. And even monolithic thinking. So, every single developer team needs to use Jenkins and needs to use this for logging and that for metrics and so on and so on. So we've got this expectation that it all needs to be the same across every single team. So there's lots of different kind of monolith. So first off, we need to kind of be aware of what kinds of monolith we've got in play before we start making some changes. So here's our application monolith, single block of stone, joined at the database. If you take out one of these services underneath, the thing's likely to fall down. Maybe not. Maybe you'll be able to deal with it. There's us building one big monolithic build. Here we've actually got small components, but we're bundling together. I'm going to run out of photographs very soon, right? You can see I've worked quite hard to get photographs that are, and here we go. I couldn't find a photograph that was suitable for monolithic thinking. Did you know, this is completely irrelevant now, did you know there's a website online where if you send them a picture of your pet from the front and from the side, they'll create you a soft toy version like that? Anyway, that's that. What a time to be alive, exactly. So there's definitely times when we need to be aware of the danger of splitting a monolith. There's a danger of reducing kind of the domain consistency. We might accidentally duplicate data that we don't want. There's definitely additional operational complexity because we've now got a distributed system and there's some asynchronous messaging and that kind of thing. And there's a danger of the user experience degrading across different parts of the product. So we've now got 2 copies of the customer table or whatever. If we've got a monolith, we've got all the communication inside the single process, but then as soon as we split it, there is going to be a network failure at some point. How do we deal with that? And then you might have a user interface. This is a user interface from a very popular music streaming service that shall remain nameless, that is very famous for how it organizes its teams. And the user interface is absolutely dire, because you can see that different teams have been allowed to have different kind of user experience in different parts of the application. So we need to kind of choose the right technique based on the kind of monolith we're dealing with. This person here is splitting a rock called slate. It's the kind of stuff we use, certainly in the UK, for roofing. So it's very, very thin grey rock. And they're finding the natural splitting point of the material. So they're working with the material to split the rock into a useful shape. And this is an analogy I wanted to use for software. We need to find parts of the software that kind of are natural split points or fracture planes. And there's lots of different things, lots of different fracture planes, lots of ways in which you can easily split code. So the business domain bounded context, this is kind of a DDD concept. Align it to kind of profit and loss or division of the business. So something like my account versus payment versus catalog, that kind of thing. I'll go through all of these in a minute. Or will I? No, I'll go back. Regulatory compliance, sometimes the regulator might have a particular kind of restrictions. So PCI compliance, for example, if you need to take credit card data, there needs to be a set of rules around that. Sometimes it's useful to split off card data into a separate area. Different parts of the system need to change naturally at different frequencies. That's a nice place to split, so we can now allow this part of the system to go more quickly. And so on, lots of different ways to split. The point here is we can be quite pragmatic about choosing these fracture planes. That means it's easier to get our job done. We're also thinking about the size of the bit that we're splitting off. Remember from before about cognitive load? So we're looking for bits that are the right size for teams that also kind of happen to match a sensible, natural fracture plane. There's two similar related questions that we can ask to find additional fracture planes in code. And one is this: could we consume this thing as a service? Could we consume this thing as a service? Would it make sense conceptually and practically? Could we actually consume this thing? And the other one is it's kind of opposite, which is could we provide this thing as a service? If the answer is yes, then that's probably a good candidate for splitting the software, that chunk of the software out. Okay, I want to mention some really cool stuff. Does anyone have a copy of this book called Your Code as a Crime Scene? Does anyone have a copy? Oh, wow. Okay, so go and buy a copy. This is really, really awesome. Adam Thornhill, so he says Your Code as a Crime Scene. You might think, well, that's kind of a hyped up title. Adam was actually a CSI. He was actually a police forensics person. So he's actually talking, and he's mixed his actual police forensics experience with writing compilers and writing code and all sorts of stuff, and has come up with these techniques. So he's using actual crime scene techniques for software. There's a talk on TEDx and various other places, so you'll find him online talking about this stuff. It's really, really awesome. He's written written several tools actually, but one of them is called Code Mat. Mat is the Egyptian goddess of understanding. And Code Mat as a tool helps us to understand our code base. It does this in lots of different ways. One of the most important ways is to identify parts of the code base which change together over time. So I make a change to this file over here. But actually, CodeMat will tell us, well, generally speaking, when you change these files, these set of files also change. But you won't find that very easily by looking at the code base. They're in a different part of the tree structure. If you combine it with other tools like Code City for visualization, then you can get some really powerful understanding of the relationships between different parts of your code base. So if you were thinking of splitting this code base, say, down the middle there, but let's just say for the sake of argument that this big blue block at the bottom right always changed alongside the green block, then if we split the repository down the middle, we'd have a problem because we'd then have to commit into 2 repositories every time. So the code forensic stuff is useful for loads and loads and loads of things, but including helping us to work out whether we should split code in a repository. And one thing Adam calls out in his book is really take care about naming of subsystems, because badly named, information-poor abstract names are magnets for extra unwanted responsibilities. And he's done a lot of analysis in this stuff. Okay. I'm going to skip through chunks of this section. We've been collating and curating some team patterns online for a while at devopstopologies.com. If you're interested in how teams relate, have a look. It's all Creative Commons, share-alike stuff, so you can send us a pull request and what have you. So there's lots of collections of patterns on there. What we've found, though, is that there's really three main kinds of team that are useful to have: product team, platform team, and productivity team, 3 Ps. Component team as a kind of optional extra if you need it. And it's worthwhile arranging kind of internal teams in this format, unless you've got a good reason not to. And the talk from Noah earlier on kind of suggests a situation where you're sufficiently advanced not to kind of need something more templated like this. But we've got a productivity team helping the software product teams to do useful stuff, which is kind of similar to what the production engineering team at Facebook here seems to do. But here's some important stuff. Generally speaking, align code repositories to system boundaries. So if we've got some deployable things, if we're going to run it and we're going to deploy and run it, it should probably be in its own repository. You might be able to get away with it without, but generally speaking, it's probably best starting off with it in its own repository. So if you can use a monorepo, which is where you put all your code into a single big repository, if your organization has published a scientific paper on computer science. So that's basically just Google. Does that seem fair? They'll find natural or available fracture planes for splitting a monolith with the team in mind. There are some situations in which you should not split a monolith. I'm not going to dwell on it, but we've worked in a situation where the VMs needed 56 gig of RAM to work. The CI build took 50 minutes. The VM took 30 minutes to start up, and it was basically an ERP system that someone had thrown into the cloud. So don't do it in those situations, but you can think about it almost everywhere else. Right, I want to run through this recipe. I'll do it quite quickly. So the summary is this. First of all, before we start splitting a monolith, we need to instrument it. Once we understand the data flows and the fault responses, then we can start aligning teams to possible segments of the monolith and then start splitting it off. But the really key thing is that we get an understanding of how this monolith actually works at runtime before we start kind of designing different subsystems and components and things. So here's a monolith, right? It just looks like this. Well, actually, it's not kind of homogeneous, right? Because we've got different packages or namespaces or whatever inside the monolith. So there's already some internal organization. What we're going to do is use something that's quite familiar, which is the kind of, so if you send a parcel by a web like tracking service, you end up with something like this, where you've got concepts of kind of event ID, so it's been arrived, in transit, delivered, this kind of thing. And we've also got a kind of tracking ID or correlation ID. So this is fairly straightforward concepts from real life, if you like. We can start to build a set of event IDs that relates to our service, our software, our component. So it could be we've started the application, or we've removed an item from a basket, or whatever. And it's the stuff that's interesting for the development team. We don't instrument absolutely everything. We instrument the stuff that's interesting for the development team and useful. And then we expect, so we inject a correlation ID at the top, a request ID in effect. And conceptually, we're expecting this to flow through down the left-hand side of this monolith in a nice fashion and generate a couple of events. And we expect then to be able to use something like Kibana or whatever to search for that stuff in our log aggregation solution. We're bringing these logs together. So we're kind of using logging as a vector to make distributed systems more, actually more observable, which is what Noah was saying earlier on. So what happens if we do that? Well, if we do this, we discover, let's say in this case, we discover that actually the request flows into this blue component in the middle. And we go, oh yeah, I forgot about that. We did some work on that like 3 months ago, and we left some bodge or left a to-do comment in there. We're going to fix it later. We forgot that actually the call goes into this blue component. We actually need to address that. We want the call to go straight down. And also down here, there's a cluster of 4 event IDs at the same thing. So maybe this service is trying to connect to a remote service and it's failing, or there's some sort of flip-flop going on and it's logging the same ID the same event many times. There's something wrong here, and we're using log aggregation to actually observe that and better prepare our code before we do some split. So what we're going to do is fix these problems first. We're going to make sure it doesn't call out to the blue bit, and we're going to fix that kind of bounce down there in the orange section. So we've fixed it now. The request now flows through just the left-hand part of this monolith. It's still a monolith, but it now flows through the bits that it should do. And we fix the kind of flaky event. And then at this point, we can say, well, that's quite interesting, because that part of the monolith is about the right size for one team to take on. We've asked this team over here. They said, actually, yeah, we could take on that slice. That feels about right in terms of cognitive load. And we've mapped that to a particular part of the business domain. So that's going to be one of the product teams. And then we can start to map other bits of the monolith to other kinds of teams. So in this case, we've mapped a total of 3 slices of the business domain, but then it turns out, let's say, there's a bit at the bottom right which is really awkward and gnarly and needs like a PhD in maths to be able to work on it, so we've decided that's a component instead. And then we can start splitting off the segments one by one. We should expect to have separate builds, separate infrastructure, separate deployments, different kind of deployment lifecycle, and so on. So it's really important that we make the team needs and responsibilities come first. As part of this, we're always being aware of what the team needs and is happy to do as part of this process. It's also really, really important to invest in build and release engineering. I think we had a question down here before that related to build and release engineering. And what we've seen is that there's so many organizations that are struggling because build and release engineering, so helping with continuous integration and deployments and containerization and things like this, that kind of investment is often absent. And it acts like the oil in the machine. And if there's not enough oil, then the machine's going to grind to a halt. And it's so common to see an absence of investment in that area. That's really crucial. So that is basically all I've got. Here's the recipe in full, and here's the slightly short version. So instrument the monolith first, understand, so grok the behavior, understand the behavior of the runtime of the monolith, start to align teams to different bits of it, where there are sensible fracture planes, and then start to split off the segments, making sure that we invest in build and release engineering. So here's the summary. Here's how to break apart a monolith without destroying your team. Have to work out what kind of monolith we're talking about first. Maybe use some of the code forensics from Adam Thornhill or some of those kind of tools to just have a look at the code base. Look for these fracture planes. We don't want to make our lives harder than necessary. Look for the natural fracture planes in the code that we can use to split. Be aware of the cognitive load for the team. We don't want to give them something that's way too big that they're just not going to be able to handle. And then use the monolith splitting recipe that we've just had a look at there. The key thing there is instrument it first. And that's pretty much it. Oh yes, we have a one-day workshop all about splitting a monolith. So kind of hands-on practical stuff. We explore some of the tools from Adam Thornhill, CodeMat, things like this. So if you're interested, get in touch. And that is it. That's all I've got.
Okay, who would like to ask Mr. Skelton a question? Mr. Hardy's got one in there.
Matt, super stuff. My question is, some years ago, team dynamics, groupthink, all that stuff was fashionable, terribly fashionable, and then suddenly it wasn't anymore, very, very unfashionable. Do you think we should be bringing it back, or should we avoid it like the plague?
So So the question was around group dynamics.
Is this not working? It is. Sorry. No. Many years ago, team dynamics, groupthink, all that kind of stuff was very fashionable. And then suddenly it wasn't anymore, and it went extremely unfashionable. Do you think we should now be bringing it back or continuing to avoid it?
So I don't know enough about that to be able to say we should bring it back. What I know is that we should definitely think about making sure that teams are empowered to actually own the stuff that they're working on. And that means a sense of safety, it means the right kind of culture, it means that, an awareness of the fact that they're providing a service in effect to other teams, or what it feels like to interact with that team. So I don't know whether we should bring stuff back, but we should certainly be very conscious of team dynamics, of the way in which teams interact, and the value of having a high-performing team, certainly.
Okay, great. Got a question over here now?
When you talked about breaking apart the monolith, and you talked about logging and looking for a way through the system and seeing if there's somewhere that it kind of goes off somewhere else and then comes back, and you spoke about, we can pull that part back in, we can fix that part of the code base and then break it off. What would you do in the scenario where your monolith is a bit of a sprawling mess and it's highly coupled all over the shop? At what point would you say, if any, this is too big of a job to fix the monolith, we need to just kill it? Or would you say, no, invest 3-6 months in really breaking these bits apart, fixing those coupling all over the place issues?
The first question I would ask is, how much revenue is that monolith generating? If the monolith is generating like 0.5% revenue, then just start again. If as usually is the case, the monolith brings in 95% of revenue, then you have to work with what you've got, because that's what's paying your salary. So be realistic about people talk about, it's the legacy system, we don't need to worry about it. Well, that's what's paying your wage and your holidays and everything else. So you have to be realistic about the value to the organization. And if it's bringing in lots of revenue, or really, really important in terms of the service it's providing, let's say it's a government service, we have to start there. That's a working system. Now, it might not be a very nice working system, but it's still a working system. So at the very minimum, it provides our kind of test comparison when we're building something new. So we have to invest the time into understanding how it currently works. If you just say, let's re-platform and build another version, you'll miss really crucial aspects of how that system currently works, which is why it's so important to instrument and take the time and effort to understand what's going on.
Wise words there. There's a question there, red shirt.
Yeah, so looking at your list, I see, is this a top-down list? Because
this is in order, so I would start with instrumentation, yes.
Okay, because I think that investing in build and release should be something that probably it would be important even if you still have monolith.
That's a very good point. So instrument, yeah, you're absolutely right. Investing in build and release engineering, those capabilities should actually sit across the whole lot. You're absolutely right. But 1, 2, 3, 4 is the order in which we've found it best to work. You're right. The investment in build and release engineering should be spread throughout the whole, all of these activities.
Cool. We've got any more? Ben.
Just one thing I noticed in terms of splitting recipe, really great, really like it. In terms of after grokking behavior, so you talked obviously about the flow of data, but what about actual data itself? Contracts between the data and the actual, say, the broken down monolith into separate services and separate teams, and managing that post splitting up the monolith. Because that's actually normally quite a tricky part in teams, is how do you manage data between the two contracts?
Okay, so it depends, right? But working out where to store the definitive copy of that data is important. Also working out whether you need a definitive copy is also important. Certain kind of data, you need a definitive version. So in transaction record, that kind of thing, certain kind of data, it's actually fine to have a copy and a local version over here. So actually getting a data architect involved and being very clear about the different data requirements and responsibilities is the first step on that. And then you can say, well, actually, then we can push this data feels more documenty. So there's a certain kind of data storage that's more suitable, and this data feels more relational, so we need this kind of data storage.
Does that come as part of 3 or 4 then? Because obviously you're aligning teams, but you need to have an idea of what your data is prior, and you've got splitting off by segments 1 by 1. So which order?
Yeah, it's somewhere in alongside 3 and 4 is where you're going to do that. Yeah. I mean, you can actually put some tracing into the database right at the very beginning. So you can have that correlation ID going right into the database, and that helps as well. Then you've got it's stored in the database or in the event stream too.
Any more questions for Matthew? Okay, I've got a really important one. So we talked a lot about the splitting up the monolith and the different types of monoliths. Sorry, what actually was the URL of that site that you can put your cat pictures into to get a 3D?
Where even is that? It's called Cuddle Clones, I think. I do not own any shares in it, but I should do because I've given this talk like so many times. Where is it even? Up here, right?
Who wants to see the cats again? Yeah, we all want to see the cats again.
Is it Cuddle Clones? I think someone have a look.
There it is.
That one, right? I think it's Cuddle Clones, and it costs like $300 or something to do it. It's just crazy.
Previous one. Next one.
Oh, sorry.
We want the cats up here, Matthew.
Sorry,
Yay.
yeah. There we go.
All right, that's made my evening.
Crazy.
That's brilliant. Sorry, in all seriousness, brilliant talk. Thank you, Matthew. Thank you very, very much.
Thank you.